Hi students, today we're going to be talking about Assignment 2. You're going to find Assignment 2 under the Assignment tab, and there it is, Assignment 2. The due date is given. I'd like it as a Microsoft Word document, and you have the same choices either to work independently or with a friend with a 10-point deduction. Assignment 2 is a PDF file. The data is in the COVID-19 file, the same file you used for Assignment 1. So we're going to exit out of that, and we're going to open StatCrunch. Now, I'm not going to be using the COVID-19 file. We're going to go to the StatCrunch website because this is a demo. Now, this could happen to you. You might be told that, oops, you have a problem, that you need to sign into StatCrunch. And what you're going to do is you're going to bypass that by just refreshing your page. When you refresh the page, things are good. Now, since you've already downloaded COVID-19 and used it in StatCrunch, you should be able to find it in My Data. Of course, I've used it, so there it is. But we're going to be using mass data today because this is a demo. The COVID-19 file is for your assignment. So Assignment 2 is all about correlation, regression, scatter plots, and interpreting them. So my demo is going to examine the relationship between median family income and math SAT scores. So we're going to, for demo's purposes, go under Stat, Regression, Simple Linear. And the X variable is going to be median family income. And we're going to see what is the impact of median family income in predicting the math SAT score, which is our dependent variable. We're going to leave hypothesis test checked, and it's very important to scroll down to the bottom of this dialog box because we also want to plot the fitted line, and we would like to look at the residuals. So both the plot the fitted line and the residuals need to be checked off. And we're going to compute. So if I slide this output aside, what is really important, of course, is the regression equation. And here is the regression equation, which you can eventually copy and paste into your assignment document. And here is the correlation coefficient, which is 0.865, and here is the R squared, which is 0.748. So let's go to the assignment. So as I prepared this demo assignment, I copied and pasted the regression equation, but I only kept 2 or 3 decimal places. The second part of your assignment is going to ask you for the slope of the regression line. Our slope is positive. If the slope had been negative, I would have had to put a negative sign here. And I rounded it to 2 or 3 significant decimal places. The next part of your assignment is to interpret the slope. The slope is the change in y, which is the change in math SAT score, over the change in x, which is the change in median family income. Now, a change of $1 in a median family income is not much of an increment at all. When we speak about changes in median family income, we're talking about thousands of dollars. In fact, if we go back to our data and scoot this aside, median family income is $13,000, $116,000, $78,000. So increments of maybe $10,000 makes a lot more sense in terms of comparing one community's median family income to another community's median family income. So I've changed the difference of one to differences in $10,000s of dollars. So I multiplied numerator and denominator by 10,000, which means moving this decimal point 10, 100, 1,000, 10,000, moving this decimal point 4 places. So we're going to interpret the slope, and you read from the bottom up, the change in x first. For every increase of $10,000 in the median family income, and this isn't per student, this is per family income in a particular school system, there is a predicted increase in the average math SAT score of a school system of 13 points. Notice I used the appropriate units. The change in Y is points on an SAT score, and the change in income is dollars, increases in increments of $10,000. The next question on the assignment is going to ask you for R squared. R squared was 0.75. That's called the coefficient of determination. The next part is going to ask you to interpret R squared, and I'd like R squared accurate to 2 decimal places. So, what part of the studied variable, what part of the math SAT score does median family income explain? A school's, now and this is not individual children, a school system's median family income explains about 75% of the variability in the studied variable, which is the school system's average math SAT score. You're going to be asked to go to the scatter diagram. So the output actually contains 2 pages, one with some statistics, and the other page has your scatter plot. Now, depending upon the computer you use, you might have to take a screenshot of this and then look for the screenshot and insert it in your document. So you are going to take that image, however you get it on your computer, and insert it in your document. The next question is going to be to comment on the scatter diagram. The scatter diagram looks like it's a positive linear relationship, and the points seem to be very close for the most part to the line, the prediction line. So I would describe this as a strong, not moderate, but a strong positive linear relationship. After all, it explains 75% of the variability in math SAT scores. The next question has to do with the residuals. Now, I could have asked you about positive residuals, but I think on the assignment I asked you about negative residuals. So let's talk about negative residuals, but the idea would be the same if I had asked for positive residuals. So we're going to go back to the StatCrunch output, and I'm looking for negative residuals. That is points below the prediction line. Here's a point that is kind of far below the prediction line, and here is another point that is pretty far below the prediction line. Another thing you can do, since you saved the residuals, is you can go over to the column of residuals, and you see this little arrow? You can pick sort ascending. So that's from the smallest to the largest. So the negative residuals are going to come up first. So the most negative residual is a residual of minus 69. And let's check and see what city that corresponds to. We're going to scoot this down a bit. That corresponds to Worcester. So what about Worcester? Worcester had a math SAT score of 379, and that is 69 points lower than school systems with the same median family income. The next lowest residual is Middlesex. Middlesex had an SAT score of 603, which is pretty good. However, if you look at the median family income, it was pretty good too. It was $220,000. So, in terms of predictability, the math SAT score of 622 was 67.7 or 67.8 points lower than other school systems with the same median family income. All right, so that's what we got by sorting the residuals. Let's clear those rows. Now, if we were going with our gut feeling and put a little pink box around this because it looks to be a low residual, it looks to be far away from the regression line on the low side. There it is, Middlesex. If we were to put a little box around this because visually it seems to be very far away from the regression line, there it is, Worcester. So whether you do it visually or you do it by sorting the column of residuals, you get back to the same two cities and towns. So let's do a little interpretation. The two most negative residuals are Worcester, with a median family income of $52,577, which is on the low side, with a very low math SAT score of 397. In fact, it is 69 points lower. Let's put it in English, a nice English sentence here. On average, Worcester schools scored 69 points lower on the math SAT exam than school systems with the same median family income. Now let's move to Middlesex. It had a very reputable median family income of $220,000 and actually a pretty good math SAT score. However, it had a negative residual. And what does that tell us? It tells us on average, Middlesex schools scored 67.8 points lower on the SAT exam than school systems with the same median family income. So you do want to be careful when you interpret these residuals. Let's go back to the data again. What is being studied? If we scoot over here, what we're studying is school districts. We're not the units that we're studying are not individual children or individual students. They are school districts. Okay? So that's why when I phrase my conclusion, I talk about Middlesex schools and Worcester schools, not the children in Worcester or the students in Worcester. It's about the schools in Worcester. So I hope this helped you. What, of course, you have to do when it's all over is you have to take this and you have to save it. You have to save it as a Microsoft Word document somewhere on your computer, on your desktop perhaps. I've already saved it, so I'm going to replace it. And then when you go back here, you're going to go back to your home page, and you are going to go to Course Tools, and then you're going to go to Document Sharing, and under Assignment 2, you are going to upload your document. I'm not going to do that. Upload your document, or I'll show you what happens. You're going to upload your document. The owner is me, and we're going to upload it. Oh, I have to browse for it. And where is my document? It's in here, and it's the there it is, the demo. Okay, there's my document, and then I will upload it, and the description can just be Assignment 2. Might not be a bad idea to put my name on it. And then add entry. And there it is. So I have uploaded my document, and that's how you would upload your document. So I hope this helps, and if you have any questions, just feel free to email me.